Now, before we go to these logic statements, remember that generally logic is confusing. So, logic chapter or mathematical reasoning chapter is not for humans, it is for the computers. Okay. So, when we are let us say designing a robot, okay. So, when we are designing a robot, we have to give robot some instructions to understand and react based on the situation. Okay. So, for example, if robot is let us say walking in this direction, if there is an obstacle in front, take a left turn or take a right turn. So, if we do not write this in the program, then robot will straight away go and hit the wall. Okay. So, this is going to happen. So, to make sure that robot reacts and robot acts on its own, we have to program it. While programming, we use the mathematical logic concept. Okay. So, these statements are actually instructions to the robot. Okay. So, here are basic statements of what are the standard types. Okay. So, let us say this statement generally means P implies Q. Okay. So, you already know, before we go to this, you already know what happens to the truth table and how to get the OR, how to get AND, okay, what is the negation. Here I am just explaining it. Okay. So, suppose let us say if there is P implies Q, so this is generally confusing to students, so I am explaining this. Okay. The reverse of this is Q implies P. Okay. Wait. Okay. So, P implies Q, if that is the statement, the reverse is Q is implied by P. Okay. Now, converse means it is the reverse. Q must be implying P, that is the converse. Okay. Now, inverse is no P is implying no Q, that is the inverse. Okay. And no Q implying no P is the contrapositive. Okay. Okay. So, now let us quickly solve one or two questions before we close this. Okay. So, let us take one question here. Okay. Here statement P says Suman is brilliant, here Suman is rich and Suman is honest. Okay. Now, I want to find the negation of the statement which is Suman is brilliant, dishonest, if and only if Suman is rich. Okay. So, if Suman is brilliant, it is P, Suman is rich, okay. Suman is rich, that means it is Q, and Suman is dishonest. Now, Suman is honest means it is R, Suman is dishonest means it is negation of R. Okay. So, here the statement goes like this: Suman is brilliant and dishonest, so P and negation of R, okay, and if and only if, okay, if and only if. So, that means here it must be double implies. Okay. So, this way we can create the logic. So, here just check which matches with this. Okay. P and negation of R, where is it? P and negation of R, and Q is double implied. And then what is asked? Find the negation of the overall statement. So, we have to find the negation of this overall statement. Okay. Now, because if and only if is involved, so if I take these two statements and flip them, it does not matter. So, we can also write this as negation of Q if and only if, that means double implies P and negation of R. We can also write it this way. Okay. So, this way we can make statements. Okay. So, several times questions come like this: a statement which is linguistically given and representation is asked. So, I took this question. Okay. Now, let us look at a different variety. So, we want to find whether this statement is equivalent to which of these statements. Okay. So, now how do we do that? The idea should be to go for the truth table. Okay. So, make a truth table here: P, Q, P implies Q, Q implies P, like this. and check if truth tables match or not. Okay. So, if truth tables match, then you can say that those two statements are equivalent. Also, you can use the concepts of Boolean algebra. So, you can, if you just read through the notes, there are some basic ideas. So, you can use those concepts also to prove them. Okay. So, due to shortage of time, I am not solving this, but that is the major idea. Whenever we try any problem, there are only two paths. One path is the truth table. Okay. So, other part is the Boolean algebra. Okay. You can prove it by using any one of these two ideas. Okay. So, now let me just take one question. Okay. So, this is based on the concept that a statement is tautology, contradiction or contingency. Tautology is a statement which is always true, okay, and contradiction is a statement which is always false, and contingency is neither. If a statement is not always true, not always false, it is the contingency, it is a mixture of both. Okay. For example, if I take a statement like this, P or no P, then this is always a tautology. Okay. So, we can always check this with table also. Okay. So, now if a statement is neither tautology nor contradiction, it is contingency. Okay. So, now let us take an example for that. So, check if the statement is tautology or contradiction or contingency. Okay. So, what is the best way? Make the table. So, I will make the table here. PQ, we want negation of P, negation of Q, and negation of Q implies negation of P, this must be there, and P implies Q also must be there. Okay. So, let me just take it here. So, P here, Q here, P implies Q here, negation of P, negation of Q. Okay. So, these are the total possible cases here. Okay. Now, P implies Q. Now, to remember P implies Q, I have a statement. Okay. To remember P implies Q, so you can remember this statement. If hard work, okay, then success. Okay. That means, if you do hard work, you can get success. Okay. So, now check, let us if this statement is true or not. Okay. So, if you do hard work, then you will get success. Okay. So, statement is correct. So, result is T. If you do hard work, you do not get success. So, if hard work is T, success cannot be false. That means, if you work hard, you will definitely get success. Though this statement is false, so overall truth value is false. Now, if you do not work hard, then you will get success. That is the meaning of this F and T. So, this could be true, because sometimes by luck or fluke you may also get success. Tukka bhi lag sakta hai. Okay. So, that means here it is true statement. Okay. Also, this means if you do not work hard, you do not succeed. So, this statement is also true. So, this way you can remember the P implies Q. So, to remember P implies Q, remember this statement. If hard work, then success. Okay. So, here we can say that this is T, this is F, this is T, this is also T. Okay. Now, similarly, let us go for negation of P. F here, I am just taking the negation. T here, T here. And similarly, for negation of Q, of F here, T here, F here, T here. Now, let us take negation of Q implies P. So, here we will get T, here we will get false, here we will get F implies T if no hard work, Okay, if you work hard, you will not get success. That's the wrong statement. If you don't work hard, you will still get success. So true. This is also true. Okay. Now we have to take double implies of these two. Double implies of these two. Okay. So double implies will happen only if it is multidirectional. So it is like from this statement, if I take this as, let's say, A, and if I take this as, let's say, B. So we should get A implies B and also B implies A. Okay. So that means even if one of them is false, then result is false. Okay. So this overall statement can be taken here. T and T will give us T, F and F will give us T, T and T will give us T, T and T will give us T. So if you observe this, we will get all possible cases as truth only. So this statement is always giving us truth value T, which means it is a tautology. Okay. So this way we can verify if a statement is tautology or not. Okay. So that's it for today. I hope you have learned some beautiful ideas, especially from the statistics. I spent more time on statistics because they are confusing ideas. I hope you liked those techniques. Okay. So prepare well, do well, and strategize well, perform well. Okay. So have a great learning day. Learning shall never stop.